Here we go.
So let's take a look at this type. Gotta plug in my smartphone. I always forget this. There it is. Okay. So this is our procedure for solving trigonometric functions, or trigonometric equations. Write all terms as variations of sine, cosine, or tangent. I've got cosine. It's cosine squared, but it's all just cosine, right? Then, does the new equation have a squared trig term and a non-squared trig term? Well, this equation has a squared trig term, but it doesn't also have a non-squared trig term. Like, there isn't also a cosine x here. It's just cosine squared. So, emphasis on the word and. Right? We don't have both of those. We just have the squared trig term of cosine. So we're going to go this way. Use inverse operations to isolate the trig term. So I need to get this. Again, the objective here is to end up with a statement where I've isolated the trig term as just cosine x. That's our aiming point. Once we get to there, well, I'm not going to go all the way back. But once we get to there, we can use the unit circle to solve for x. But we have to get to this first. So when you look at what's written here, to get from there to there, I've got to get rid of this 12. So the first thing I'm going to do is divide by 12. Now when I do that, I'm going to avoid decimals completely right now. Okay? So we have cosine squared x equals 1/4. Now, just as a reminder, like we haven't accomplished our goal. We haven't reached to this point yet, right? As a reminder, cosine squared x is really cosine x quantity squared, right? It's just a shorter way of writing this. We just put the 2 there so that we don't have to write the parentheses every time, okay? So then the question is, what inverse operation do I have to do? And it says this here, you may have to take a square root. Well, this is exactly that scenario where we have to take the square root of this so that we have just one cosine x and not cosine x squared. So we will take the square root, and then we have to take the square root over here. Now here's where things get a little weird. I'm going to take this and move it down. Because what happens when we take the square root of something? Well, when we are the operator and we have to take the square root, the outputs of this are both positive and negative. That's the first curveball in problems where we have squared terms, is if we have to take the square root, we have to include both the positive and negative outputs from that. And then this is really the square root of 1 over the square root of 4. When we take the square root of a fraction, we can separate that into the square root of the top and the bottom. Okay, the square root of 1 is 1, and the square root of 4 is 2. So now I'm here. Now I've reached that point where I have the isolated trigonometric term, cosine x. So then we ask ourselves at this point, okay, I know that my answer is a pair or more of angles, right? What angles produce a cosine value of plus or minus 1/2? Because we're doing cosine, right? What angles have an x coordinate? We're doing x coordinates. We did y coordinates in the opener, if you recall. Here's our opener. We asked the same question in the opener when we got to here. But we were talking about y-coordinates because we were doing sine here. We were solving with sine. Oops. Now we're using cosine, so we're asking ourselves what angles have an x-coordinate of 1/2 or -1/2. We can look for both of those, okay? So then you just work your way around the unit circle, looking at the x-coordinates and finding the positive and -1/2 that exist there. Now, I don't need a unit circle for this because this is my job and I've been doing pre-calculus for over a decade, so I know that the x-coordinates of 1/2 are at pi/3, right? That's positive 1/2 for an x-coordinate. We jump into the second quadrant where the x-coordinates get negative, right? When you think about the unit circle, right? Anything here has a positive x-coordinate, anything down here has a positive x-coordinate, anything over here has a negative x-coordinate, and anything down here has a negative x-coordinate. And the values that are at 1/2 are pi/3, 2pi/3, then we shoot straight down that diameter, and we shoot straight down that diameter. So we have pi/3, 2pi/3, 4pi/3, and 5pi/3. Plus 2πn for all of the coterminal angles. Now, the one thing I will tell you is when you're doing Math Excel, because I know Math Excel can be very finicky, can be very picky, sometimes they ask you to solve, and then they say for angles between 0 and 2π. So sometimes they want you to stop at 2π. If you see this as a part of the directions on Math Excel, if I could give you one hint about that, if you see this where it says, limit your answers to the interval from 0 to 2π, then you would just box these in and you wouldn't write that. But if they don't include this, then they're saying, tell us all of them. Well, what are you going to do? You're going to keep writing pi/3, 2pi/3, 4pi/3, 5pi/3, 7pi/3, 8pi. Are you going to keep going? Good Lord, no. There's an infinite number. So we just say, and I'm going to add all of the coterminal angles that are included with that. That's what that means. Okay?